This is notes page 15 and 16. And we are going to talk about math properties. And these properties you're going to continue to use all the way through high school. Okay, and there's just the ones that really stand out are the ones we're going to go over today. These are the ones that you're going to just keep seeing again and again. So I'm reading the properties. It says, sometimes changing the order of regrouping numbers in an expression makes calculations simpler. Math properties define rules that create equivalent expressions. That is two expressions with the same value. This is very useful when simplifying, okay? So the commutative property, and these might be ones you've learned, the commutative property defines the rules that orders of numbers when adding or multiplying. Okay, so what it's saying is if you do 5 plus 4, that is the same thing as 4 plus 5. 5 plus 4 is 9, 4 plus 5 is 9. So when you're just adding, okay, order doesn't matter. So if I do 2 plus 3, that's the same thing as 3 plus 2. So this is the commutative property when order doesn't matter. The commutative property of multiplication is the same idea. Like if I had 7 times 2, that's 14, but 2 times 7 is also 14. And if I did 3 times 8, that's the same thing as 8 times 3. They're both 24. So order doesn't matter when you add, and it doesn't matter when you subtract, or excuse me, it doesn't matter when you multiply. Okay, those are the two places where it doesn't matter. So, sorry, I have the yawns today. So on this one, what would be my commutative property in equal expression would be 12 plus 17. Okay, and then prove it by simplifying. This is 29 and this is 29, and those two things equal each other. So same thing here. This is 3 times 15, and then prove it by simplifying. 15 times 3 is 45, and 3 times 15 is 45. So I just proved that order doesn't matter when you add and multiply. And it's called the commutative property. Okay, and so you kind of have to recognize that word. There's a lot of different properties, but there's only a couple that I'm going to ask you to remember their name. And commutative is one of them. Okay, so the other one that I am going to ask you to remember is called the associative property. And this says the associative property defines rules for grouping of numbers when adding and subtracting. Okay, so I'm going to kind of just show you an example here. If I had 1 plus 9 plus 6, and I said do this, and then 1 plus 9 plus 6. So I kept the numbers the same, but I changed where the parentheses are. I would get, on the first one, I would get 10, and 10 plus 6 is 16. In the second one, I would get 15, because that's the parentheses, and 1 plus 15 is 16. Okay, so the grouping, where I put the grouping symbol does not matter. So if I did another one here, 3 plus 7 plus 2, and 3 plus 7 plus 2. So I didn't change order. I'm just going to change where those signs are. So on the first one, I would do 7 plus 2 is 9. And then I would do 3 plus 9 is 12. In the second one, I would do 3 plus 7, which is 10. And 10 plus 2 is 12. So you get the same answer. I'm not changing the order. I'm just changing where the parentheses are. Okay, the same thing works for multiplication. So if I had 3 times 2 times 5, and I still did 3 times 2 times 5, but I moved the parentheses. In the first one, I'd have 6 times 5, which is 30. In the second one, I would have 3 times 10, which is also 30. Okay, and so I do the same thing maybe on the next one, 4 times 10 times 1, and if I put the parentheses there, I could also say 4 times 10 times 1. So my order stayed the same. My parentheses changed. So in the first one, that's 10, and 4 times 10 is 40. In the second one, it's 40, and 40 times 1 is 40. So you get the same answer, okay? So if I look at the example here, my numbers are going to stay 1 plus 4 plus 8, but now I'm going to move the parentheses. And if I work this, this would be 5 plus 8, and that's 13. And this would be 1 plus 12, which is also 13. So you do get the same answer. So on the next one, if I change not the order, okay, associative does not change the order. It changed what's grouped together. So in this one, I'd have 6 times 8, which is 48. And in this one, I'd have 12 times 4, which is also 48. So 48 equals 48. Okay. All right, next is the distributive property. Okay, so the distributive property is another one where I expect you to know the name. Okay, it's one of the more important properties. So what the distributive property is, it defines the distributive property. Distributive property defines a rule for multiplying a number by a sum. Okay, so in this one, I would have like 5 times, parentheses, 6 plus 2. Okay, and so what I can do is I can distribute that 5 and say 30 plus 10, which is 40. Okay, you could have added 2. And so sometimes you're not going to want to use the distributive property. I use it more with big numbers than I do these ones. So you could do 6 plus 2, which is 8, and 8 times 5 is also 40. Okay, on the next one, you would have 3 times like 9 plus 4. So you would do 3 times 9, which is 27, and 3 times 4, which is 12. And I can do 27 plus 12 is 39. That would have been the same thing if I would have added those together. That's 13, and 3 times 13 is also 39. So I'm not saying that I always use the distributive property, but sometimes it can make, when I multiply big numbers, it can make it a little easier. And I'm going to show you some examples of that. So they want me to do the distributive property on this. Okay, so if I do the distributive property, that would be 2 times 9 plus 2 times 14, right? So I'm timesing the 2 into both of them. So if I do this out and I prove it, this is 18 plus 28, okay, and 18 plus 28 is 46. Okay, this also is going to be 2 times 23 if I added them together, which is also 46. So you don't have to use this distributive property, but sometimes, like I said, if it's big numbers, it works a little easier. So on the next one, I'm going to multiply 7 times 5 plus 7 times 8. 7 times 5 is 35. 7 times 8 is 56. If I add those together, I get 91. Okay, it might have been easier to add because here you got to do 7 times 13. I do believe that's on your pink paper, and that is 91, and you're always allowed to use that. So that's what it means by proving the distributive property. Okay, so 8 times 15, this is what I mean by big numbers. So maybe you're sitting there and you're like, I don't feel like doing 8 times 15. Couldn't you do 8 times 10 plus 5? Because I think I can do that pretty easy. That's 80, right, plus 40, which is 120. So sometimes you'll see people use this. Same thing like on the next one. 4 times 39, I would have to write that over here and I would have to multiply. So that's 36, carry the 3, 12 is 15. So it's 156, right? Okay, but I didn't want to have to write that. So could I split that up as 30 plus 9? Because I know 4 times 30 is 120 and 4 times 9 is 36. If I add that together, it's 156, and then I don't have to do the adding. Okay, so I would like you to try number 10. Split it up and see if you can split it up. I would split 10 up by doing 20 plus 6, because that is 26. And I know 9 times 20 is 180, because 9 times 2 is 18, and then I add the 0. 9 times 6 is 54, and then if I add them together, I get 234. Okay, so just making it a way of a little bit easier. So again, if I just try this, this is a big number, so I would do 40 plus 3, because that's 43. 7 times 4 is 28, and then you're adding a 0, plus 21 ends up being 301 when I add it, because I can kind of add that in my head. Okay, so the distributive property isn't something I use all the time, but it is something I use when I'm multiplying bigger numbers. So these three properties are the ones that you'll see all the way through high school. There's a test that they make you take in high school. It's called the ACT. These properties will be on the ACT. These are the three they think you should know. So on the first one, number 11, if I figure out what it is, did I change, this one is 794, this is 794. So I didn't change order, but I changed what's inside the parentheses. I moved the parentheses. So if you move the parentheses, it's associative. And then they make you say like property of addition. But I am not so worried about that as long as you know associative. Okay, now on the next one, it didn't change. The 7 and the 3 are still in the parentheses, but their order has been changed. So this is the commutative property of multiplication, because you're multiplying. I think I just spelled that wrong. We'll pretend. Okay. All right. On the next one, you've taken that thing and you've distributed it. You've taken the 9 into both of them. So this is called the distributive property. And it's not of multiplication or addition. It's kind of a combination of them. Okay. On the next one, this is really important. We don't have a property with division or subtraction. So this is none. I guess in the directions they said right and valid, but whatever. Okay, I would like you to try 15 and 16. Pause the video, try 15 and 16. So 15, you changed order. So this is commutative, and it's the property of addition. Okay, on the next one, I wrote this. I took 20 and I split it up. So this is the distributive property. Okay.